Okay, here we go with Chapter 1, Section 4. This is our second video lesson of Level 1. This lesson is going to be covering segments, rays, parallel lines, and parallel planes. We're going to discuss intersecting lines and skew lines as well. But these are the primary category or primary terms that we'll be looking at. Let's get started. First of all, we're going to talk about segments. Segments are a part of a line containing all the points in between the two endpoints. So the major difference here between a segment and a line is this segment has a start and an end. It has two endpoints, you would say. And so the red is a segment. Now, if you extend it with the dotted black parts, it becomes a line. Notice the naming of segment AB. No arrows on top of A and B. This implies that it starts at A, stops at B, or vice versa. Starts at B and stops at A. So, an interesting question would be, what is the difference between line AB and segment AB? And to think about this on a few different levels. One, the difference is line AB goes on forever, whereas segment AB has a finite length. We can actually measure it. We can actually say, oh, it's 2 inches long or 5 inches long. Another thing is that line AB has no middle, no midpoint. Segment AB, we could find the midpoint, the middle of it. You could continue this question and say, what are the similarities? Because there is one major similarity that's kind of interesting. A line contains infinite points. Well, a segment contains infinite points. Although the segment is exactly 5 inches long, there are infinite points in between that start and stop point, no matter how big the segment is. Well, then what about saying segment AB and segment BA? Are these the same segment? Yep. Segment AB contains all the points in between A and B. Segment BA contains all the points between B and A. Well, those are the same points. And since the name is just a description of what we see the same thing. Let's go to rays. Now, a ray is a set of points starting at one endpoint and continuing forever in one direction. Well, here's ray XY, the red part. Again, the dotted black part creates line XY. When I say ray XY, this will start at X and it goes through Y. We always start at the first letter and go through the second. If I was to write ray YX, that means start at Y and go through X. Notice I did not do this. That would be bad. We do not draw the arrow above pointing to the left just because maybe the ray goes to the left. The arrow above when naming a ray will always go to the right. When writing the name, it goes to the rules of reading and writing. We read from left to right. The start is on the left, where we go through is on the right. When we start to have rays that go in odd directions, we don't try to draw the arrow in that direction. This is still ray XY. Start at X, go through Y. So we come to this question, and from this picture, are ray XY and ray YX the same ray? No, those are not the same ray. One of them starts at X and ends or goes through y. The other one starts at y and goes through x. Technically, they go in two different directions. You can never have two rays be exactly the same if they don't start in the same spot. That's the first thing you have to look for. If they don't have the same first starting point, then they're not the same ray. Okay, let's talk about opposite rays. Now, opposite rays have to share that endpoint where they start from, kind of an odd word there, start and end, and they extend in opposite directions. So, in this picture, we have ray PL and ray PQ. Here's PL, here's PQ. They both start at P and they go in opposite directions. Now, ray LP and ray LQ, those are the same ray. Those are not opposite rays. They both start at L and they go in the same direction. Ray LQ and ray QL, those are not opposite rays. Just because they go in opposite directions does not make them opposite rays. They must have the same start point. So, LP and LQ are the same ray, same starting point, extend in the same direction. Leads us to this question of, what do we need for two rays with different names to be the same ray? Here's ray AB. Right next to ray AB is ray AC. Ray AB and ray AC are not the same. In this picture, ray AB and ray AC are the same. So we could say here, ray AB, ray AC are the same. But in this picture here, ray AB and ray AC are not the same. So we have to answer this question. What is needed for two rays with different names to actually be the same ray? It's not enough to just say they have the same start point. They must also go in the same direction. There's two criteria. They must have the same starting point and go in the same direction. These have the same starting point. They go in different directions. These have the same starting point, but they go in opposite directions. Therefore, opposite rays. Let's move into lines again. Parallel lines. Now, rays can be parallel, segments can be parallel, lines can be parallel. The key is they must go in the same direction. It's not just that they never intersect, because segments are short. Segments may not intersect and also not be parallel. If we extend them into lines forever, they will never intersect. Best way to think of it, they go in the exact same direction. A couple things in these pictures and things that are important here. This little arrow in the middle of the line, that is the symbol that marks that those lines are parallel. If we see a little arrow marked in the middle of two lines, it's telling us they're parallel. Here's the symbol when we write it. Line M is parallel to line N. That's why I put, this is red, is parallel to. Line AB is parallel to line DC. You can look here, here's line AB, here's line DC. Notice that in the picture they are actually segments, but we can picture them becoming lines. Last thing, parallel lines have to be coplanar. You might think, well, wait a minute, what about lines EB and line HC, or maybe AF and DG? Those appear to go in the same direction, but I don't see their plane. If they go in the same direction and are parallel, they are coplanar. Imagine that this line AD was a roll with wrapping paper on it, Could we unroll that wrapping paper all the way to FG? Sure. It would create a new wall going through the middle of the box. Coplanar. Okay, so we look at this picture. What line is parallel to line AH? We got to look at line AH, and it's not even there. We got to visualize it in our mind. What line is parallel to line AH? And the correct answer on this one is B. Line BG would be the parallel line. AH, BG. Okay, we move on to a different type of line. Skew lines. If we read this, skew lines do not lie on the same plane. That's really all you have to say. They are neither parallel nor intersecting. So if we take a look, what does this mean? Parallel, not intersecting? Line AB, line CG. Try to look at those two lines. Line AB, line CG. Line AB is going side to side up on the roof. CG is going front to back on the side. Let's put those in. The blue lines are skew. If we continued them forever, they would never hit each other, and they're not parallel. They don't go in the same direction. These are the example of non-coplanar lines. So that brings us to the two categories of lines. They're either coplanar or they're not coplanar. If they're coplanar, they either intersect or they're parallel. If they're parallel, remember, we can take a piece of wrapping paper and pull it across to the other line and form a wall. If they're coplanar but they intersect, let's draw this and get a little bit of an idea. How many points do we need for the first line? 2 from our last lesson. Point A, point B. How many points do we need for our second line? Well, 2. But they already share B, so I can put point C right here. And I have line AB. I have line BC. Well, in order to create intersecting lines, I only needed 3 points. And those 3 points formed a triangle, guaranteeing that they are coplanar. No matter what happens, if 2 lines intersect, they are coplanar. If they go in the same direction, they're parallel. If they go in different directions, but don't intersect, that's called skew, non-coplanar lines. So, just to see if we got this, can 2 lines be coplanar and intersect? Or sorry, can they be non-coplanar and intersect? No. Because if they did intersect, they would be coplanar, and we would fail to meet the first part of the question. Okay. Wrapping things up. Planes. Planes can either be parallel or intersecting. There's no such thing as skew planes. Parallel planes are like the ceiling of the room and the floor, or the 2 side walls that could go on forever and never intersect. Intersecting planes, like we saw in the last lesson, will always have a line. They will always form a line, like when 2 walls come together. There's a wall, or the line, as the corner of those walls. So, parallel planes, intersecting planes. Those are the only 2 options. Here's a little lesson quiz for you to take a look at. Again, pause the video at this point if you would like to try to figure out these questions. We will be going over these questions tomorrow in class. Or not necessarily tomorrow for the video, but after we have seen lesson 1-4. This was chapter 1, section 4, about rays, segments, parallel lines, skew lines, and planes.